everybody, thanks so much for joining me on today's update of the Hockey Puck project product journey. I really got to come up with a name for this thing instead of just randomly saying words at the start of every episode. But if you remember from last time, I was working on debugging the screen code. I was going to try and use the Particle Programmer Shield, but there were kind of a lot of steps to set that up, so I figured I'd give it a try using print line statements. It's an old debugging trick for those that have been programming for long enough before all the fancy IDEs, but even more so for people that have been debugging firmware where a lot of times you don't have the fancy IDEs. So that's what I did. It took me about 2 hours, and I was able to get to the bottom of it. Now, I haven't entirely nailed this down, but I nailed it down enough that I feel comfortable having gotten around it and moving on. And what I found was that there was actually not really any line of code that I was doing that was doing something crazy like accessing invalid memory or anything like that. What I found out was that there was a delay statement deep down in my code that's doing a lot of things. I was using a particle delay call. And for those of you not familiar with Particle, it's similar to Arduino. There is a call called delay. You pass it a number of milliseconds and it will basically wait. However, the particle delay call is smarter than that. It is a multitasking call, meaning while the delay is happening, while it's waiting to execute your code, it's also doing a lot of other things in the background to keep the photon connected to the particle cloud and servicing all of those things like the network routines and all of that. What that means is during a delay, you switch off of the user thread onto the system thread in the particle firmware world. What that was meaning for me is, from what I can gather, is I was doing so much stuff deep down in my stack of things. I was deep down in a function call, and then according to the documentation, if you look really deep in the documentation, it will task switch between threads about once every millisecond, likely on an interrupt. And that was causing me grief. Like, that task switching was blowing the photon up. And that's where I don't understand that entirely. It shouldn't do that. It should be able to multitask and switch those threads seamlessly without having issues. But the fix for this was something new that I learned in the particle world, which is called the atomic block, which sounds like a super awesome WWE wrestling move. I'm gonna call it WWF. I didn't really watch wrestling growing up past the WWF days, and so I never really followed WWE. So I'm going to call it an awesome WWF move. Sorry, worldwide, I can't remember who has the WWF that they had to change the name. But anyway, we're getting sidetracked. What I found out is the atomic block, it's like a macro that you can put around a block of code in your particle firmware, prevents that task switching. So if you do an atomic block, open bracket, anything in between or under that before the close bracket will be executed on the user thread. It will not switch back and service the other, will not service the other photon routines. So you don't want to block too long, because then you're going to prevent things like the particle cloud connection from renewing your network. I found that if I did long tasks in the particle block, I would go from flashing cyan to flashing green, which means I've lost my connection to the cloud. I imagine you'll eventually lose your connection to your Wi-Fi network. And so you got to be careful with what you do inside of the atomic block. But that was it. All I had to do was, as part of my routine for the screen, there's a busy line. And the screen will take the busy line high, will pull it high whenever it's doing something, saying, hey, listen, don't talk to me right now. I'm busy rendering a screen or something like that. And so you just have to wait. Well, in my code, I have is the screen busy? Okay, wait a few milliseconds and then try again. Well, it's that code, that delay that happens all the time throughout the screen routines that was causing everything to crash. So I stuck an atomic block around just the delay for like 5 milliseconds, and everything works like a champ now. I've got text displaying because I've implemented the Adafruit micrographics library as part of my class in the firmware, and so everything is working amazing. I'm really pleased with how it's going, getting the screen code cleaned up and running. And so that was our ultimate problem. It was just a delay call. It wasn't even some crazy thing I was doing. It was just an interaction on this particular hardware platform of how my code was interacting with the system firmware. And so that is it for today's episode, the atomic block. is the new thing that we've learned in this journey. And so if you have any questions about that, I may have the answer. You're welcome to stick them in the comments below. I'm happy to try to help. Otherwise, I hope to see everybody back tomorrow for the latest update on the, I'm not even gonna say it, this product thing.